Welcome everyone to another episode of Office Hours. I'm your host, Stuart Newsom, and I'm excited to have Natalia Arzeno-Gonzalez with us today. She's the Chief Data Scientist here at Infinix, and she joins us because we're talking about a topic with artificial intelligence and machine learning that she is clearly an expert in. And if you haven't heard her talk about this subject before, you're going to know what I'm talking about at the end of this session, for sure. So, hey, Natalia, how you doing?
Hey, doing well. Thanks,
Good.
Stuart, for having me. Yeah, happy to
Yeah.
talk a lot about this.
Yeah, awesome, awesome. So tell us a little bit what you do here at Infinix. Not everyone has a chief data scientist. We feel
Mhm.
very privileged to have you for that reason, but for other reasons, obviously, as well. But just tell us exactly, what does a chief data scientist to do?
Yeah, so as Chief Data Scientist, I essentially participate in all aspects of anything that has to do with data science in our company. So this could be evaluating use cases for is this a good candidate for machine learning or AI, um, working on the actual implementation, working with the product teams, and then we see the model from ideation all the way through deployment. And at that point, we're still involved. So we model monitoring is pretty key in order to keep models that are working well for the company and for our clients. So yeah, it's a job that I really enjoy. I get to work across different products, and it's all things data science. Yeah.
Awesome, awesome. So today, as many of you may guess, we're going to dive into machine learning models, what they are, how they work in the context of AI, and the key considerations for healthcare providers when they're looking to leverage this technology. So we'll cover how MLMs, as they're commonly called, can address RCM specific challenges, how they adapt and scale, and whether they remain relevant as AI continues to evolve. So as always, I just want to remind everyone, if you've joined us before, if this is your first time to be with us, we will have a Q&A session at the end. So feel free to drop your questions into the Q&A section. And we'll be happy to address as many as we possibly can at the end of the episode. So Natalia, we're going to dive right in. And I think it's just very appropriate to go ahead and ask if you can define machine learning models, or as I said earlier, they're commonly known as MLMs, in the context of AI. I think it's important to define it because when people hear AI, they may have different perceptions regarding that. So can you dive a little deeper into that?
Yeah, so AI is everywhere now, right? Like I feel like even people who are not in the data science field just hear AI several times a day. And so AI as a whole is a bigger field. So it has many subfields that cover different types of models, and machine learning models are a component of that. But in a sense, they're also the foundation of AI. So at a very high level, it's math. They're mathematical frameworks. You use machine learning models to identify patterns or to make predictions in your data. And so the machine learning models are trained on data, and that's how they learn these relationships between either your data inputs and the outputs, or just the data with relationships within the data itself. And these relationships are then used to provide insights. And so one big thing of machine learning models is that they can analyze these patterns and find these relationships that are way more complex than anything that a human brain can analyze or anything that a human can process. So I think in the past couple of years, we've been hearing a lot about like Gen AI models. Gen AI models go through this whole data input, training objective, data predictive output process. So Gen AI models are a type of machine learning models. And AI as a whole will also encompass things like RPA, so robotic process automation. Also classical natural language processing, or NLP, which that's maybe where LLMs have been gaining a lot more traction on. But you don't need a process learning something else in order to be considered AI. So you can have human-designed rules-based systems. Those are considered AI because they help processes become more intelligent. In a sense, you're injecting business rules into your process. classical optimization algorithms like used for work scheduling, those are not necessarily machine learning models, but they also fall under the umbrella of AI.
Mhm.
But one thing to keep in mind is that a lot of these non-ML models can also be combined with machine learning models in order to, in the end, provide like a more intelligent system.
Right, right. So that sounds like more of an orchestration. I know we speak of that
Mhm.
term orchestration here at Infinix, and when we talk about that, that's what you just referenced. You know, there's different levels of AI all working together to accomplish certain tasks, to accomplish certain frameworks, to make certain decisions, if you will. Um, so with that in mind, you know, how can MLM specifically help with RCM specific challenges? I would imagine there's all kind of applications you can apply to that.
Mhm. Yeah, that within RCM, you can think about the different use cases. If you want to make a prediction, if you want to understand patterns in your data, then that's a good place to start forming that use case and then trying to dig deeper into, is machine learning the right solution for this? So if you think of like claim denials, you can use machine learning models to try to predict claim denials or to prevent claim denials once you understand what are the factors contributing to these claim denials. Now you can also have just like a claim scrubber that maybe does not require machine learning
Mm,
in it. It's just doing some series of comparisons, and that's again a kind of AI that's a rule-based system. You can, I think one place where we see machine learning a lot, especially on the language side, is in computer assisted or automated coding. So machine learning models or language models can be trained to be able to identify what diagnoses are present in some medical notes or what procedures are available in the data. Now, going down that track of looking at notes, if we go deeper into the language side of things, then you can think of like looking through payer policies, prior authorization, medical sufficiency policies, that sort of thing, contracts and compliance. You can also look at the patient access side of things and prior authorization. This might potentially be a combination of looking at payer policies and also looking at data in order to determine whether a prior authorization request might be approved or denied. Another source, which a great source of data for machine learning models, is the data that's in the electronic health record. And there you can also get more of this tabular data that you can use more traditional machine learning on. You can also use the data to identify patterns. So if you want to cluster patients with some objective in mind, then machine learning could be a good tool for that.
wow, there's all kind of applications out there. So I would imagine you'd have to kind of uh, analyze the specific task that you're trying to accomplish or a specific data you're trying to analyze. And I
Mhm.
imagine, you know, understanding even deeper how MLMs work, you know, can you go into that a little bit from the data input to the generating of decisions? You know, what makes it smarter over time, if you will? How does it learn? Because
Yeah.
it's the name, machine learned learning
Yeah.
models.
Yeah, no, that's great. I think it's pretty important for people who are using machine learning models in their business to have some at least basic understanding of how they work, right? It's not magic,
Mhm.
it's math essentially. So uh, at a very high level, you have data, you have math, you have an output. Like that's all there is. But if we dig deeper into how they're trained, how the models are used for inference, how the decisions are generated, then we do get into a bit more complexities that are very useful to understand. So I think the very first thing, same as we're evaluating a use case to determine whether it's a machine learning use case or not. If we do determine it could be a machine learning use case, the one of the first things that we have to consider are not just what data can we use, but what is it that we're trying to predict,
Mhm.
and how are we going to kind of like teach the system to predict that. And so this is what's called the learning objective, the training objective. And this is some sort of mathematical formulation of your problem. And this is also where you need to be very careful in how these are defined. And that's something that as data scientists, especially in whatever domain, in our case, in the healthcare domain, we need to understand what is what does the data look like, as well as what is the business use case. So if I say I'm going to predict claim denials, then I can say, okay, I want to predict claim denials with really high accuracy. Now, if I only have, say, like 3% denials in my system, then I can just tell you, okay, you're never getting a claim denial. I have a system that's 97% accurate, also a system that's completely useless because it achieves high accuracy, but the training objective, in a sense, is maybe not as well thought out for the data and the use case itself. So defining this objective is a big part of what we do. And then we also need to maybe collect the data or build the data set from existing data resources. If we're doing what's called supervised machine learning, then we need a label. We need to know the outcome. What is it that we're predicting? And we need to make sure that we have that for the data that we're using as well. Now, most of the time that we spend developing models is spent on the data itself. So having very high quality data is key in many models. So garbage in, garbage out. And with, I think the Gen AI, a lot of companies are emphasizing that what they're doing in advancing their models, a lot of it is just sourcing more high quality data. They don't just source everything from the internet. There's a lot of auditing and cleaning and QA that goes into what data is actually fed into the models. So
So you're
cleaning,
kind of purifying it, right? So, to a certain extent.
yeah, you want to make it useful data because otherwise you're just passing in a very noisy signal. And then that's going to be harder to identify these patterns in order to get an accurate output. So we have a training objective, we have our data, then we go through a lot of data cleaning and pre-processing, turn the data into something useful. And that goes into the math of the model training. And that math is meant to update like the parameters in the model, the numbers in the model in order to like maximize or minimize your training objective. And then we have some model evaluations, we iterate. There's a lot of iteration in this process. Now, from a consumer point of view, a lot of that is hidden from view, right?
Mm-hmm.
So at the point of what you see is at the point of inference. So you see the data passed in, then there's a black box, and then you get a prediction. But it's important to understand what it is that is going on inside that black box, especially is this a model that will work for my use case, for my data? So if you have different data distributions between what the model is trained on and what you're predicting on, it's not going to perform as well as someone claims if the evaluations were done on a different type of data set. So these are all things to kind of keep in mind. Now you asked about making the model smarter, right? Machine learning. So we do that via feedback. It can be these thumbs up, thumbs down feedback that you might see in many applications. It could be some sort of data correction. So the output was wrong, and I pass the correct output so that goes back into the model. And then also just obtaining new data. So perhaps the model initially was built with a small amount of data, but as you have practices in place to collect more high quality data, then you can use that newer data in order to retrain the model. And that could just be like a batch retraining or some sort of like incremental updates to the system. And that will depend on what kind of model itself was trained to begin with. But yeah, a lot of information and a lot of different ways to make the model smarter.
Yeah, so it's really a lot to consider there. When you unpack it like that, when we're out there and people are asking about AI and creating automations and using generative AI and whatnot, I hear this with, some top executives at health systems, hospitals, even specialty groups. It's very important that not only do you understand someone who can have some sense of empathy for the task that you have to create, like they know and understand the pain of denials, the pain of prior authorizations, the pain, of working those denials, submitting claims, coding, whatever the case may be. It's important to have someone who understands the issue. But as you laid out, you also have to have an understanding of building the right framework with the right data. And if the data, and as you said, purifying that data, but also how is that machine learning model going to continue to evolve? How is it going to learn? So it sounds like there's just a lot in play because you may, again, the policies change, regulations change. So that data has to be fed in there as well. And then there's also self-learning, I'm sure. So it's real fascinating it's almost like I want a task, I want to perform this task. And as you say, it's like math. And
Hmm.
it's not your typical formula you'd put in an Excel spreadsheet, right? So
Yeah.
there's a lot to consider there. So with that said, I kind of touched on this, but my next question is, what are the most common misconceptions about MLMs in healthcare? How can providers overcome them? I think you've alluded to that a little bit in that answer you gave from the previous question. But there are a lot of misconceptions, and I've seen organizations where they've put some AI in place, whether it's RPAs, whether it's automation, whether it's generative AI, and 16 months, 18 months goes by, and it was nothing what they wanted. It was giving them, it just didn't work out. So they either had to start over or then invest more in adjusting that. So can you just kind of cover some of those common misconceptions that lead them down that path?
Yeah, I think there's a lot to consider, as you said, and a lot of misconceptions as well. I know one big misconception is almost that like bigger is always better, newer is always better. So if you have a use case where it is just a simple set of rules that needs to be considered and you get your output, you get your decision. You don't need a really big machine learning model in order to achieve your goal.
Mhm.
So for that, perhaps you do just build a rule set and a system that can take care of that. It's just a like very deterministic system. Now, if you have like hundreds of rules or thousands of rules and they're evolving over time, as policies change, as your patient population changes, then that's where machine learning would come in, right? So then it's no longer sustainable to have a model where you just have a set of curated rules because the model could be able to learn a lot of those rules. And perhaps with your small rule set, an equivalent model wouldn't be able to get to like 99% accuracy. But as your rule set grows, then that's a better use case.
Mhm.
For let's say like more recently we're hearing Gen AI, Gen AI, Gen AI. If what I have is an Excel spreadsheet without like free text notes, Gen AI is probably not what I need as a technology. Like if we have a tabular data set, then a standard machine learning, more traditional machine learning model that is not a Gen AI model would probably be a better candidate. So just because Gen AI is newer and shinier does not mean it's better for every application. And we have models that have existed for decades and they're still widely used. And that's for a reason, it's because they do work well. Um, Now, aside from the newer or bigger is better, I think another misconception is probably that um, if I see a model that's being claimed as being great for the general population of use cases, not healthcare specific, then that's going to apply to me, to my use case. And this is what I need because it comes from like a company that I respect, I've just heard that it worked really well for these other fields. It doesn't mean that it's necessarily the best model for healthcare. So we talked about how models have to be trained on the data and they predict on data profiles, say, that are similar to what they were trained on. So if you have a model that's trained with a lot of just like general data and you apply it to a healthcare use case, that's not what the model is intended to be used for.
Mhm.
So the model should be built by people who understand the nuances of healthcare data, who understand the workflows, and in order to make a more useful and smarter model. So like in healthcare, the nodes have different vocabulary. Like a common word may mean something completely different in healthcare. The
That's right.
way that the data elements are related to one another, or the order that the data is generated. So like if you're trying to have a prior off like a use case, you're not going to be using billing data as an input there because the billing data is generated afterwards. So you need to understand like the workflows and the sequence and all of that. And so having it doesn't even need to be a healthcare specific model, but a model that is trained or fine-tuned. So we take a general model and then kind of tune it towards more towards your data and your requirements, then that will perform a lot better than just like a general model. And think we see that with Gen AI also, like some models that have healthcare data or more healthcare data in their pre-training data, then those will perform better on healthcare use cases. Whereas models that are just like trained on Wikipedia maybe don't understand the nuances of like ICD codes.
Right, right. Or even the acronyms that are so common in
Mhm.
healthcare. I call it the alphabet soup of healthcare with all
Yeah.
their acronyms that may be for diagnosis codes or CPT codes or certain processes for RCM. There just seems to be so many nuances that that model needs to catch and needs to be educated, for lack of a better term, on what they mean.
Mhm.
So speaking to that, and it sounds like as an organization, grows, then perhaps these models need to grow with them, um, or as their workflows evolve. So what are some considerations for scaling MLMs for organizations that are going through some massive growth, or maybe just small growth, and their workflows are evolving?
Mhm. Yeah, so as there's different kinds of growth, you can have growth as far as like for a transactional system, how many transactions are you going to be passing through this model? And then for that, then it's more of a infrastructure from the vendor. Is the model designed and is the infrastructure designed in order to handle like an increased data load and keep the predictions within some reasonable time in order to return the prediction, right? So you don't just have like a really long queue, then you're getting
Hmm.
the data back slowly. And then when we're considering traditional machine learning models, there's different ways that we can develop them. Some just from like a developer point of view, like we might choose certain libraries that are more accurate for smaller data sets, or we might use a library that handles bigger data sets better, maybe with some slight trade-offs because like law of large numbers, in the end, you're going to be getting some good results with the large by just having more data. So that's something that like the developers themselves would need to consider, but the client should be aware that the increased data load can be handled by the model itself. Now, there's also growth as far as like the number of use cases or the workflows. And so as these evolve, as the company grows, then I think there's some points in which one needs to reevaluate whether the original model is still the model that we should be using.
Hmm.
So, I mean, and you can start very simply. I had a rule-based model that doesn't work anymore. I need a more complex model. But you can also think of, okay, we now have this other data source. Should we revise our modeling approach because this data could be useful in making the prediction? So is a new model required in order to increase accuracy just because we have more knowledge in the front end now, so that can make for better predictions. Um, as one grows and workflows change, then we have to consider whether the data is changing as well. And at times, clients or users, consumers will be the ones who would know this best because they would know like our payer mix changed or our patient population changed. And so we want to make sure that the model, which was trained with some slightly different data, can still perform well. But at times it might be the developers or the vendor who might notice these changes, especially if they're slighter changes, because we are tracking model metrics. And so we understand if the model performance is dropping over time. And that cues us into we need to not just look at the modeling approaches, but look at the data as well. And changes in data could come from just growth or changes in workflows. So yeah, so I think a few questions that need to be asked, and also just make sure to have certain checkpoints to understand that the model is still appropriate and performing well.
Right, right. Kind of do an assessment, if you will, if it's still able to perform its duties.
Mm.
So, and with that in mind, will MLMs become obsolete? I believe you answered this somewhat in a previous question in a statement. But what I mean, and obviously you answered that in the previous question as well, as you may have to have a different LML model that accomplishes that task. But I'm talking about in the context of any new development of newer AI technologies.
Yeah, so they may become less visible to the user because they'll be more ingrained into these orchestrated systems that you mentioned earlier. But machine learning's been around for decades. And machine learning is essentially math taking data in order to understand patterns, in order to provide some sort of prediction or insights. That's not going anywhere. As long as we have data, if we want to learn from the data, then that will fall under machine learning. Now, maybe we'll have slightly different terms for it, but if you have that math component, then it will likely be continued to be considered a machine learning model.
Mhm.
Now we still see that, like I mentioned earlier, like tabular data will still perform better often with more traditional machine learning approaches rather than some technology that's meant for like text, like Gen AI. We could see some shifts in how models are being used just because of what new technologies come out. Maybe bigger models are trained or made more widely available, might be used some more often than they currently are. We just need to evaluate the use cases for that. But I think we'll still see machine learning models either being used in conjunction with these bigger models that are nicer and shinier and newer. And also, we're seeing machine learning used and just not called that. So if you have something like intelligent RPA, now where does that intelligence come from? It's from some sort of inference that was made at some point. That inference may have been trained on prior data that it's seen. So that inference is the result of the machine learning model. But so no, they won't be obsolete. They might just be less visible or called something else.
Yeah, right, right, exactly. Well, that's it for the questions that I have. We are going to turn it over to see if there's any Q&A, any questions from the audience. So again, just remind everyone, if you do have a question, please put it into the Q&A section of this Zoom application. We do have one question that has come in, and is what should providers consider when balancing automation with human oversight to ensure MLMs align with organizational goals? That's a long question.
Yeah. Okay. So human oversight, I think it is pretty key in order to just kind of understand that the models are doing what they should be doing, right? We can have some sort of automated oversight also, or even oversight performed by like newer Gen AI models of us in a sense. But human oversight is what gives us human feedback also. So if we're saying human oversight with like maybe monitoring metrics and understanding the model performance, like that's key just to ensure that the model is performing with its original objective, right? The objective changes, maybe the model needs to be revisited. But also, it's good for people to interact with the model. Maybe they'll notice some nuances that can be addressed in model training, or that might reveal something that is different than expected in the data. So I'm not sure about the balancing part, but if you have automation and you have a model, then it can't go unchecked. Like at some point, it's not going to perform well. So you need to have some sort of process for understanding the model performance, understanding if there's any model drift or data drift, if your data is changing, and a process for feedback. So human oversight can go into a few of those elements, be it viewing some sort of report or metrics or dashboard on models themselves, um, or on the outcome of the model. So you're seeing like, okay, well, the model was wrong this one time. Okay, if it was wrong one time out of 100, is it really like a really high cost scenario where that one time really matters? Or is it that you're seeing some patterns that are incorrect in the predictions? But very key will be providing that feedback so then the model can become smarter. It can learn from these changes that have happened or these observations that humans have made as well. And so it's important for the models to be able to incorporate that feedback into becoming better for the future.
Yeah, so it really kind of addresses that question, is machine learning going to replace humans? And I think your answer really substantiates that yes, there needs to be oversight, there needs to be supervision, there needs to be small adjustments, small corrections to those models. So it does. It takes a lot of monitoring, for that. And maybe not a lot, but maybe you could have machine models who monitor the other machine
Mhm.
models, and then you could actually have someone still look at that one machine model that's monitoring all the other machine models. So there's a hierarchy that I see that could be built within that to help with that balance.
Yeah, you can have alert systems, but the
Mhm.
alert system could be
Mhm.
built by a person who knows what it is that you have to look out
Right,
for changes.
right. Awesome, awesome. Well, let's see. I think we see another question here. Okay. And what types of safeguards can be taken to protect private health information within a machine learning model or other AI tool? That's an excellent question. It's on the compliance side of the
Mhm.
fence. So,
Yeah, so in healthcare, data privacy, security, compliance, that all is paramount, right? So I would say either the consumers of the model or the developers of the model, you always have to be very hyper aware that nothing is being sent to some public API, right? No one's typing in private information into your free ChatGPT UI. That companies make very clear, we can use this data, we can use it for training our model. And so it is now saved there forever. You can't take it back.
mhm,
I think as a consumer of a model, then you just want to make sure that your data complies with any sort of standard that you're following, HIPAA regulations, right? So there's regulations around encryption of data, like in transit at rest, regulations around like what safety measures and security measures have to be placed on your system. Like cloud deployment isn't bad. You just have certain safeguards in place, and you have like local deployments as well, which also need safeguards in place. So um, yeah, just don't send out any data into the internet. And always make sure that any
right.
tool, any library that's being used complies with like privacy and regulations that you need. Um,
Hmm.
yeah, I'm
Right.
not sure what to
Exactly.
add.
Yeah, and I think also, you're not off the hook if the machine learning model violates some kind of HIPAA violation. It's still you're just not off the hook if that happens because it's being trained, it's input, it's a responsibility to monitor that. Another reason why there's that balance between humans and these machine models to make sure that it's not drifting off. But again, if you put those safeguards in place, following the typical high trust or ENAC. There's all kind of other privacy organizations that help with certifications and accreditations. But essentially, it's all about making sure you have those safeguards in place and going above beyond because cybersecurity is obviously top of mind this year for obvious reasons that people are aware of. It's really kind of come to the forefront. So that's an excellent question. Really appreciate that being asked. All right. So there's no more questions, Natalia. I really appreciate you joining us today. This was excellent. A very good session. I'm sure we'll have you on again in the future. I hope you'll be willing to come back and help us out with another episode.
Yeah, thank you, Stuart. Yeah, I'm always happy to talk data science.
Oh, awesome, awesome. So with that, we'd like to thank everyone else for joining us today. Be sure to tune in for the next episode of Office Hours. Be on the lookout for invites to that. We're just happy that you joined us. And so I want to make sure everyone has a great and safe holiday next week. So want to see you back on future episodes. Thank you so much.